So how do you use stacks, which are a last in first out structure, to implement a queue, which is a first in first out structure? Conceptually, a queue takes things in from the back and a stack takes things in from the top. And this is where the problem arises. If we want to pop something from the queue, we're popping from the front, whereas from the stack, we're popping from the top. Return values do not match. So how do we solve this? Another stack, of course. So how do we go about implementing the second stack data structure? If the first stack is empty, you push the first value on as normal, but when you go ahead to push the second value onto the stack, something interesting happens. We run a while loop and take all the elements in the purple stack and put them into the green stack. Then we push 8 into the purple stack, and then we take all the elements in the green stack and put them back into the purple stack. What we have done over here is successfully reversed the order of elements in the stack and enabled 5 to be in popping position for both data structures. We can now continue this process for the remainder of the numbers. And that, JDs and Lentilman, is how you implement queues using stacks. The space complexity for this is O of n because we do have another data structure, and the time complexity for the push function is also O of n, but the time complexity for all other functions are constant. The common gotchas are the following. For this one, most of the code is pretty straightforward, but when you're implementing the push function, make sure you're performing the while loop only when the stack is not empty. Then ensure you actually push the x value in before bringing everything back in.